Hello everyone, welcome to Vision Tech Solutions channel. This is a new lab of CCIE Enterprise Infrastructure series. In this lab, I'm going to show you how to configure reliable static routing with enhanced object tracking. Let's look at the topology that we have for this lab. We are going to work on router R1 and R4. Just in this area, and what we want to do, as you can see here, between router R1 and R4 we have two paths. We have one path from the VLAN 146 from their Ethernet interface, and we have another path to reach R4 from the DMVPN tunnel. So R4, in order to reach for example, the loopback interface of R1, it can go through the Ethernet interface of gig 1.146, and it can go through the DMVPN tunnel to reach to R1. And because we are not going to deploy any dynamic routing like OSPF or ERGRP, we are using the static routing. So we want to configure two static routes, one from VLAN 146 from this sub interface to R1, and one from the DMVPN tunnel. And the primary path should be 146, and the secondary path or the backup path should be through the DMVPN tunnel. So in case the primary fails, we should route the packet through the DMVPN tunnel. But here we might face the issue that if, for example, from R4 we are pinging the R1's loopback, but if this interface on the R1 fails, R4 will not detect the failure on the other side. It can detect the failure on its own interface, like if gigabit 1.146 fails, it will use the backup route. If we change the administrative distance of these two static routes, but in case the other side, if this interface fails, it cannot detect it. And in order to address this issue, we need to use the IPSLA with enhanced object tracking, which I'm going to show you in this. Now, first, go to the tasks actually that we are going to do. So with R1, with IPv4 static route for R4's loopback prefix through the DMVPN cloud. So we have to first configure a static route for R1 going to R4 through the DMVPN tunnel, because we want to establish a static routing between these two routers. So I have all the routers here, R1, R4, and R5. They are ready. So in R1, we want to configure a static route that goes to R4 through the DMVPN tunnel. Let's look at the IP address configurations. Show IP in brief. So we have the DMVPN tunnel 155.1.0.1. This is the interface on gigabit 1.146, which is this interface. On the R4, show IP in brief, show IP interface brief. So this is the tunnel interface. This is actually the DMVPN tunnel interface on the R4 side, and this is the gigabit 1.146. So configure R1 with the IPv4 static route for R4's loopback prefix through the DMVPN cloud. So in this case, because right now if I ping the loopback of R4, which is this one, 155.1.0 150.1.4.4, 150.1.4.4. We don't have connectivity because there is no routing between these two. So I'm going to IP route 150.1.4.4, which is the loopback interface of R4 through the DMVPN tunnel. So the DMVPN tunnel address of R4 is 155.1.0.4. 155.1.0.4. Okay. So now we have a static route from R1 to R4's loopback through the DMVPN tunnel. So we should have a static route from R4 to R1 on the way back. Otherwise, we cannot ping. So still, we should not be able to ping. And the reason is the packet goes, but it cannot return. So on R1, on R4, actually on the other side, we have to, with the primary IP4 route static for R1's loopback prefix via its VLAN 146. So primary route. Let's look at the tasks. So I'm gonna skip this part first. I will configure just the static routes without the IPSLA. Then I will show you what happens if you don't configure the IPSLA. We'll do the verification, and we have a backup route through the DMVPN cloud with administrative distance too. So we skip this part for now. So one primary path through VLAN 146, one backup path through DMVPN with administrative distance of 2. So on R4, which is, okay, this router, I want to configure primary static route to R1's loopback through gigabit 1.146 and the backup through the DMVPN tunnel. IP route 150.1.1.1, which is the loopback IP. If I go up, I will show you. This is the loopback IP 150.1.1.1 with the mask of 5. So the primary path should be through gigabit 1.146. So it should send it to the gigabit 1.146 of R1. So which is 155.1.46.1. So if you look at this one, 155.1.146.1. If I don't put, so here you can see if I insert the question mark, I can put the administrative distance. Administrative distance is a value that shows which route has more priority, okay, in the routing table. So administrative, the lower is the better. So, but the lower administrative distance means the route is more preferred. So if I don't put anything, it is assuming that it is 1. Okay, and I'll just go to the last task. For the backup route, I want to do the routing, configure the static route for the R1's loopback prefix through the DMVPN cloud. So that was through the VLAN 146. Now, if I want to configure the same IP route 150.1.1.1 with the same subnet mask, now it should go to the DMVPN of tunnel of R1, which is 155.1.0.1. 155.1.0.1. 155.1.0.1. But here I changed the administrative distance to 2. Now we will check what happens, why we specify 2 routes here. So right now from R1 I should be able to ping. Yeah, as you can see I can ping because now the packet goes and it can return. On R4 ping, on R4 show IP route static. So as you can see in the routing table I can see the route with the administrative distance of 1, which is 1.146. The reason is because it has the administrative distance of 1 and this route has the administrative distance of 2. Now if I trace route 150.1.4.4, actually it's going to the connected route. Now if I go to 1.146, which is this interface, and shut it down, ping 150.1.1.1, I can ping it, but now let's trace 150.1.4.1.1. So now you can see that it is going through the DMVPN tunnel and then it goes to R4 to R1. So it's not using this path, it's using the backup path. And show IP route static, as you can see, it is now going through the DMVPN tunnel and it's not going through the directly connected link. If I go up, I will show you that previously it was 1.146.1, but now the static route is shown because this interface is down, and the next route with the administrative of R2 will be installed in the routing table. Now let's go to int gig 1.146 and no shut. So show IP route static. Again, I can see that it is. Now let's think about the situation when this link on the other side goes down, and let's see what happens. So right now I can ping d.1.1 and I can ping it. And if I go to int gig 1.146 and shut that interface down, and look, it cannot ping, although we have a backup route. We have a backup route, but R4 cannot detect that this interface, this one, is down. That's why we cannot ping it. And show IP route static, and still this route is installed in the routing table, and that is the problem, because we shut down this interface. Now the traffic cannot go because R4 cannot detect the failure on the other side, and it cannot route the packet from the DMVPN tunnel. To address this issue, we need to do the enhanced IPSLA with enhanced object tracking. IPSLA, it means we have to continuously track this interface status. In case it is not available or it has failed, it should reroute the traffic or use the backup route. And we do it by doing the IPSLA. So this task, use IPSLA and object tracking to ensure the route is valid as long as ICMP connectivity exists between R1 and R4 and R4's Ethernet connection. Configure R4 to verify connectivity each 5 seconds. Ensure that at R1 it probably needs 2 seconds. And of course we have to add object tracking as well, which I'm gonna show you on R4. So what I will do, conf IPSLA1 ICMP Echo, and we have to check this interface. So we have to check 155.1.46.1 with the source interface of 155.1, or I can just say gig 1.146. So 155.1.46.1 is to show IP int brief is this interface. So we are checking this interface. So if we want to, one of the requirements is ensure R1 replies within 2 seconds. It means we have to specify the threshold and timeout, and it should actually ping or check the connectivity each 5 seconds. So frequency is in seconds, so with pi 5, timeout is in milliseconds, so it's 2000. Threshold actually should be 2000. And timeout, it should yeah, okay, timeout 2000 and threshold 2000. Then to enable the IPSLA, we say IPSLA schedule 1 start now, lifetime forever. Then we specify the track object, track 1 IP SLA1, and we have to add show run section route. So we have to add the track object to the end of the primary route. So in case the primary route goes down, it should use the backup. So the way I do it, first I will remove this route, the primary, and then what I will do, I will apply it again, but this time I put the track object 1. Okay, now let's verify if it's working. So show IPSLA summary. Because yeah, so R1 is shut down, so first I no shut the interface. Now on R4 show IPSLA, it should come up shortly. Yeah, so we can see the status is okay, and show track, the track object is up, IPSLA is working. Now we will do the same scenario. We turn off this interface. So first show IP route static. I'm using the Ethernet interface, and ping 150.1.1.1. I can ping it, and trace route 150.1.1.1. I'm using the directly connected route. Now on R1, we saw that if we shut down this interface, previously we were not able to ping 1111, but let's see. Okay, and there you go. You can see that I can ping it. And if I trace route 150.1.1.1, and I'm using the tunnel, and show IP route static, and you can see that it changed it is now using the backup route. Show IP SLA or show track. As you can see, the track object is down. When it is down, it will call the IP SLA summary. IP SLA is down, and show run section route, because we have the track object. So in case associated with the primary route, if the primary route goes down, it will use the backup route. So without this tracking object or IP SLA to check the status of the other side, like the R1's router status, we will not be able to install the backup route, and the ping fails. But when we have the what we call it the reliable static routing with enhanced object tracking, it will allow us to install the backup route. So here in this video I showed you how to configure the IP SLA. So this is how we configure the IP SLA. We have to check the ICMP Echo from 155.1.46.1 with the source interface, the threshold, timeout, frequency, and track object. So track 1, IP SLA 1, and then add it to the primary route. And we specified that we have 2 static routes, one as a primary and one as the backup. So with this verification, we concludes the lab for configuring the reliable static routing with enhanced object tracking. I hope you enjoyed this video. If you found this video useful, please don't forget to like this video and to subscribe and share it with your friends. Thank you, and see you in the next lab. Thank you.